This isn't a simulation. These are real photons captured by the JWST. And what they show is a galaxy being stripped apart. Gas is being torn away, stars are forming inside the debris, and it's happening far earlier than many models predicted. This is now the most distant confirmed jellyfish galaxy ever observed. This system, cataloged as Cosmos 2020-635829, sits at a redshift of 1.15. That means we're seeing it as it was 8.5 billion years ago. And what the JWST reveals is not subtle. At first glance, it looks like a normal spiral galaxy. Bright core, faint disk, but look closely at one side. There's a diffuse extension, pulled outward, one-sided. It breaks the symmetry of the galaxy. That's the first clue something physical is happening. This phenomenon is called ram pressure stripping. When a galaxy moves through dense intracluster gas, it experiences pressure, like wind pushing against it. Except this wind is superheated plasma. If the galaxy's gravity can't hold on to its gas, that gas gets pushed out. It forms a trailing tail. That's why systems like this are called jellyfish galaxies. Now here's where it becomes real science. Astronomers didn't just see a tail. They measured the light from individual clumps inside it. They modeled the spectral energy distribution of each region. That means brightness was measured across multiple wavelengths, from Subaru, Hubble, and the JWST. The results are clear. The stars in these clumps are young, on the order of tens of millions of years old. That means star formation is happening inside stripped gas. Not tidal debris, not merger leftovers. New stars forming in material that was ripped out. Now look at the velocity data. Gas farther from the galaxy's center shows a systematic shift. The motion aligns with the direction of the tail. That's not random turbulence. That's coherent stripping. Everything points to the same conclusion. This galaxy is losing its gas due to ram pressure. There's also a color gradient. The outer regions become bluer. Bluer light means younger stars. Again, consistent with triggered star formation in the wake. Multiple independent methods, morphology, photometry, spectroscopy, all agree. And here's the breakthrough. This galaxy sits at redshift 1.15. We're observing it as it was 8.5 billion years ago. That means dense cluster environments capable of stripping galaxies already existed at that time, earlier than many direct observations had shown. In simple terms, galaxy clusters were already violent, and galaxies were already being environmentally quenched. Return to the image. We're watching a galaxy lose its fuel for star formation in the early universe. The JWST isn't just giving us sharper images. It's pushing back the timeline of when galaxies begin to die. If one system was already being stripped this early, how many others were quietly losing their gas? That's the bigger question this discovery raises. If this kind of deep space update interests you, leave your thoughts below. Do you think environmental quenching started even earlier than this? And subscribe so you don't miss what the JWST reveals next.